Dynamic econometric model. This is a distributed lag model where yt is equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 plus ut. So here yt is consumption. It depends upon income. Yt is explained variable, and xt and xt minus 1 xt minus 2, basically x is a explanatory variable, that means income. So why is consumption depends upon income, not only current period but also the previous period. That is why consider xt minus 1 xt minus 2, and ut it's the error term. So for example, yt consider as income, consumption, and x consider as income. Consumption is not only a function of this period but also the previous period. So the general model is yt is equal to alpha plus beta naught. Here is alpha, beta naught, beta 1, beta 2 up to beta k. These beta terms are parameters. So yt equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus up to beta k xt minus k. K number of parameter is there. So distributed lag model with kth period lag. Here lag is kth period. And beta k number of parameter is there. Beta 0 is the short run multiplier or impact multiplier. Here beta 0 plus beta 1, this value beta 0 beta 1, from equation 2, from equation 1, we can see that here beta 0 plus beta 1, it's a interim multiplier for previous two period, because the parameter beta naught has the term xt current period income, and the term so beta 0, beta naught and beta 1, it's an interim multiplier for previous two period, and beta 0 plus beta 1 plus up to beta k, it's a long term multiplier. It can be considered as a long term multiplier. From this line, so the impact multiplier, it gives the change in mean value of yt due to 1 unit change in the explanatory variable, that is x, in the same period. If the delta in y or change in y it's maintained at the same rate or level, so beta naught plus beta 1 gives us the change in the mean value of y for the two period of t and t minus 1. Because the parameter beta naught, it's related to the explanatory variable, that is xt current period, t is the current period, and t minus 1 is the previous period. That is why here consider the mean value of the consumption for the two period of t and t minus 1, the partial sums, that is beta naught plus beta 1 or beta naught plus beta 1 plus beta 2, or this beta naught plus beta 1 plus the last term beta 2 plus beta 3 are called the interim multiplier. This interim multiplier. And next is long run multiplier. This long run multiplier, that is the sum of I, it's equal to 0 to k beta I. That means there is value of beta 0, beta naught, beta 1, beta 2, beta 3 up to beta k. It gives us the mean value of y for all the periods, that is period 0th period to kth period. And the standard multiplier is beta I star. It's equal to beta I. Beta I, what is beta I? Beta I is any multiplier divided by sum of the all multiplier. It is all standard multiplier. It is also called the long run multiplier. And the reason for lag, why there is a reason, there is a lag considered in this model, because there is some reason, that is psychological reason. Because of the force of habits, people do not change their consumption habits which follow price decrease or income increase, or some change in the technology. That is, suppose the price of capital relative to labor declines, that means value of capital, its or price of capital, its fall, that makes the substitution of capital for labor economically feasible. Capital is economically feasible, of course addition of capital will be in the market for labor. It's not always feasible because technological reason. And next, why there is a lag, that is institutional reason. For example, that is institutional reason number 3. For example, contractual obligation may prevent the firm for switching raw materials or labor from one source to another. So institutional reason. So these are the three main reasons. First was the psychological reason, second is technological reason, and third is institutional reason that may arise. Because of that reason, lag may arise. And the estimation of the distributed lag model, that is, if the lag are known, it is called the finite lag model. If the lag is not mentioned, then it is infinite lag model. This infinite lag model. And ad hoc estimation, what is ad hoc estimation? That is, since the explanatory variable xt is assumed to be non-stochastic, xt is assumed to be non-stochastic because the correlation between the error term and explanatory variable is 0. There is no relation between explanatory variable and the error term, so non-stochasticity is there, so we can apply Wales easily. Yt is equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus up to infinite lag model. We don't know, this is not a finite lag model considered here in this line. And last term is ut, that is error term. Here lag are not known, that is infinite lag model. Econometricians suggest that the above estimation model we should proceed sequentially. At first, regress yt on xt, then regress yt on xt, comma xt minus 1, and so on. So on means yt on xt, xt minus 1, xt minus 2, and so on, so on. The sequential procedure stopped when the regression coefficient, there is a coefficient, the regression coefficient of lagged variables start become statistically insignificant, or coefficient of at least one of the variable change sign adversely. Then the sequential procedure will stop. Other thing that is need to consider here, the koyck transformation. What is koyck transformation? That is, the koyck has proposed an ingenious method of estimating lag model. Here beta k it's equal to beta naught, beta k it's equal to beta naught lambda power k. So k its value of k it's equal to 0 1 2 up to k. It will depends on three common beta k value depends upon three common components, that is first one is beta naught, second is lambda, and third is small k. Where lambda in between 0 and 1, lambda is also known as the rate of decline or the rate of decay of the distributed lag model. Here 1 minus lambda is known as the speed of adjustment. This states that if successive beta coefficient is numerically less than each preceding, this implies that beta is that lambda is less than 1. This implies that 1 goes back into the distant past. The effect of the lag on yt becomes progressively smaller. After all, current and recent past income are expected to affect current consumption or expenditure more heavily than income in the distant past. So that means beta k is the number of parameter. This term depends upon lambda, k and beta naught. So here the main concern is that yt, that means consumption is progressively smaller effect. All current and recent past income are expected to, that means the current period and recent period income affect more on expenditure compared to distant past time period. The value of lagged coefficient beta k depends apart from common beta naught and lambda. The closer lambda is to 1, if lambda is closer to 1, that shows that the decline of beta k. Some important factor is that, or summary of this uh, these lines are beta k it depends upon beta naught, lambda and small k. K is the value is 0 1 2 up to k, lambda in between 0 and 1. Here beta is a parameter, or it's also called coefficient. So if lambda tends to 1, lambda it's basically less than 1. If lambda tends to 1, then slower the decline of beta k, the value of beta k. Here the recent past is more important, that means the recent income or current income its effect more on consumption compared to the distant past. So after discussing the transformation of koyck model, then some feature is there of the koyck model that we'll also need to discuss in this section. By assuming non-negative value of lambda, all the coefficient will have similar sign as of beta naught. By assuming lambda is less than 1, weight have given lesser weight to the distant past beta than the current one. That line is already discussed here. If the lambda value is less than 1, then lesser weightage provide to the distant past of beta than the current one. Recent past will have higher weightage and the distant past will get lesser weightage. Lesser weightage give the distant beta than the current one. And the third feature of the koyck model is here in the case long run multiplier considered previously, that is beta k, it's equal to sum of k is equal to 0 to infinity beta naught beta k, that is equal to beta 0 1 minus lambda. How to get this formula? This is a long run multiplier. This is a long run multiplier. From this line we can show that sum of k it's equal to 0 to infinity beta k, it's equal to beta naught plus beta 1 plus beta 2 up to infinity consider here. So beta naught is same plus beta naught lambda. Here beta 1 it's equal to, consider beta 1 it's equal to beta naught lambda, and beta 2 equal to beta naught lambda square. Similarly beta 3 it's equal to beta naught lambda 3, that is considered in this line, the red dot. And if taking common beta outside, in the bracket there is 1 plus lambda square up to infinity, and this is actually, we know that the here beta naught first bracket 1 plus lambda square, it's an infinite GP series, that is why beta naught into 1 by 1 minus lambda. So estimation is yt considered that is a consumption or expenditure, it's equal to alpha plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 plus up to ut. Instead of beta 1 we can use beta naught lambda. Instead of beta 2 we can use beta naught lambda square. Instead of beta 3 we can use beta naught lambda cube. So in this way we replace the value here, this line, and if we consider one period lag, that is y t minus 1 is equal to alpha plus beta naught xt minus 1 plus beta naught lambda xt minus 2 plus beta 2 lambda square. I forget to mention here, there will be a beta lambda square. There will be a lambda square here, consider double dot lambda square into that is from equation 2, if we take one period lag, that will be y t minus 1 it's equal to alpha plus beta naught x t minus 1 plus beta naught lambda x t minus 2 plus lambda beta naught lambda square x t minus 2 up to ut. So there is some mistake is there, so we can write the equation 2 in this way, that this is the right equation after taking one period lag. So if we multiply both side by lambda, we can get equation 3, that is lambda into yt minus 1 it's equal to lambda alpha plus beta naught lambda xt plus beta naught lambda square xt minus 1 plus beta naught lambda cubed xt minus 3 plus up to u t minus 1 with the term lambda. Their lambda will be there from equation 2 and equation 3. This is basically equation 2 and here equation 3. We can see that yt minus lambda yt minus 1 it's equal to alpha minus alpha lambda plus beta naught xt, and other term will cancel out, and then ut minus lambda ut minus 1. So from equation 4 we get that yt equal to lambda yt minus 1. The left hand side has minus lambda yt minus 1. It can replace in the right hand, that is lambda yt minus 1 plus alpha common, in the bracket there is 1 minus lambda plus beta naught xt, it's there, plus vt is here ut minus lambda ut minus 1. So we can represent it as yt is equal to lambda yt minus 1 plus alpha 1 minus lambda plus beta naught xt plus ut, it's equal to yt equal to alpha 1 minus lambda plus beta naught xt plus lambda yt minus 1 plus vt. There is some limitation in the koyck model, that is all the problems of ad hoc has removed, but there is a correlation between yt minus 1 and vt, that is not equal to 0. Correlation between yt minus 1 and vt, it's not equal to 0. So covariance ut minus lambda ut minus 1 into ut minus 1 minus lambda ut minus 2, that can represent very well in the previous page, that is this is shown here very well, that is covariance vt minus 1, covariance of vt means ut minus lambda ut minus 1 and vt minus 1 it's ut minus 1 minus lambda ut minus 2. So covariance is equal to lambda ut minus 1 whole square. It is covariance is not equal to 0, so there is a relation between them, that is equal to lambda here lambda ut minus 1 square, it's not equal to 0, so we cannot apply Welles because we will get the bias estimator, and yt minus 1 is stochastic. Correlation between yt minus 1 and ut not equal to 0 because vt it's within the calculation of yt minus 1, so yt is stochastic. From this last equation there is a correlation between vt and yt minus 1. The disturbance term vt will be autocorrelated because covariance between ut minus 1 not equal to 0, so there will be a problem of autocorrelation that can be detected through Darwin-Watson test. We can apply it to detect the to remove the problem of autocorrelation. That explanation it's not considered, but only the considered as a limitation in the koyck model. So in number 4 here, the presence of the lag y variable violates one of the assumption underlying Darwin-Watson test. So Darwin-Watson test can be used here. So further explanation is not considered in this section. Up to this the koyck model is considered, and after that there is adaptive expectation model and some comparison also shown that there is some similarity in the adaptive expectation and koyck model. And adaptive expectation model, suppose yt is equal to beta naught plus beta 1 x x1 xt star, that is not visible, xt star term it's not visible, plus ut. Here consider yt, that explain variable, consider demand for money, it depends upon the normal rate of interest, and u, it's a error term, demand for money, it's a function of expected rate of interest, and already mentioned that yt star is not visible. This is known as adaptive expectation model or error learning hypothesis, because agents adopt the adaptive expectations in the light of the past experience, and that will particular they learn from their previous mistake. The expectation revised each period by function omega, sorry, gamma, of the there is a gap between current value of the variable and previous expected value. So xt star minus xt minus 1 star, xt star term it's not visible, it's equal to gamma into xt minus x t minus 1 star. Here xt it's actual and xt star it's not visible, it is expected, gamma in between 0 and 1. This shows that expected value of interest, that is xt star term is mainly expected term, that is depends upon xt minus 1. Expectation of interest rate of this period depends upon the previous period's interest rate, expected interest rate, plus gamma xt actual interest rate minus parameter gamma into expected interest rate. So basically there is a left hand side, there is an another term minus xt minus 1 star, that is replaced here in the right hand side. In the next line xt star is equal to xt minus 1 star plus gamma xt minus uh, gamma xt minus 1 x t star is equal to gamma xt plus xt minus 1 term taking common outside, and in the bracket there is 1 minus gamma, that is equation number 3. And yt is equal to beta naught plus beta 1 xt star plus ut, it's equal to beta naught plus beta 1, but the term, the value xt star, it's replaced here, gamma xt plus 1 minus gamma xt minus 1 star plus ut. Yt is equal to, so just breaking the bracket term and get equation 4, and ultimately taking one period lag for the equation number 4 prime, and one period lag, that is yt minus 1 beta naught equal to beta naught plus beta 1 gamma xt minus 1 plus beta 1 1 minus gamma xt minus 2 star. From here one period lag is considered, that is yt minus 2 plus xt minus ut minus 1. Multiplying above equation by 1 minus gamma, we get equation 5, that is 1 minus gamma yt minus 1 plus 1 minus gamma. Multiply this above equation and subtract this 5 from uh, number 4 number equation, and ultimately we get yt minus 1 minus gamma yt minus 1, it's equal to gamma beta naught plus gamma beta 1 xt plus 1 minus gamma bracket yt minus 1 plus ut minus 1 minus gamma ut minus 1. So we just some manipulation of the equation to get a final result yt, it's equal to gamma beta naught plus gamma beta 1 xt plus 1 minus gamma beta yt minus 1 plus ut minus 1 minus gamma ut minus 1. So this term, this left hand side is considered here, So similarly, uh, in case of koyck model, we see that there is a term yt minus 1, and in the adaptive expectation model we can also see there is a term yt minus 1, that is the demand for money of t minus 1th period appears in the right hand side. And also there is some drawback: there is no priori guide about what should be the maximum length. Degree of freedom will be less if the period of lags is very high. N minus k, it's k number of parameter. If number of parameter increases, then degree of freedom will be less. So up to this, consider the adaptive expectation model. um, this part is not included. This part already discussed in the previous pages. So up to this, consider the adaptive expectation model in the dynamic econometric model, and other models will come in the next sessions.